Alright, so just a couple more examples of graphing using the 5 key points. And I just wanted to see a couple of different kind of strange examples that could happen, but it still fits into this idea. Right, so the first one here is if I ask you to graph y is equal to x squared minus 9, and I ask you to calculate the vertex, we'd go through and say, alright, so always for the vertex we're going to use negative b over 2a. Right, and in this case the issue comes up that if I was looking at this I would say, well, this is my a, right, that little one that's hiding there, I'm going to need that. But b is usually attached to an x value. If you remember, the standard form looks like ax squared plus bx plus c. My b is this one, and I don't have that here. When that happens, b is actually there, but it's 0. So I'm going to say in this case, if I'm trying to calculate it, I'm going to say this is equal to 0 over 2 times 1, which is just really 0. 0 over 2, 0. So I'd say for my for my vertex, it's 0 comma something. Right, so I'm going to say, let's find out what that something is. Y is equal to 0 squared minus 9. Well, 0 squared is 0, and 0 minus 9 is negative 9. Right, so in this case, my vertex is 0, negative 9. So a little bit strange case there where you don't see the b value, but you need it for the vertex. So I'm going to say 0, negative 9. That's going to be a point. Right, and I'm going to draw my vertex, my axis of symmetry in as well, because that's going to be important so we can do our reflections. So let's put in a dotted line. And if you notice in this case, it's actually going to be at 0. So if I draw that x is 0, it's actually going to be the same thing as my y-axis. So my y-axis is the axis of symmetry here. They're the same line. Right? So when I calculate my x-intercept, same basic idea as before. I'm going to say, let's put a 0 into the y part of the graph. It's going to look like 0 is equal to x squared minus 9. And then I have to factor and solve this. Right? Well, I can solve this a couple of different ways. I could factor this and say, well, this turns into x plus 3 and x minus 3 is equal to 0. Right? And that looks like when I set each of these equal to 0, I can get that x plus 3 is equal to 0, or x minus 3 is equal to 0. And when you go through and you solve those, and I'll leave that to you, you get two solutions. You get a negative 3 out of this one, and you get a positive 3 out of this one. And so I'd say my two x-intercepts are going to be negative 3, 0, and positive 3, 0. And that's going to be points that I can graph. So I'm going to go over to 3, 0, put down a point. And I'm going to go to negative 3, 0, put down a point. And it's looking like I'm getting a nice parabola. That's good. Right? And so those are two important points. Now here's the other tricky point. If I say plot the y-intercept, well, if I come up here and I say, well, y-intercept when I plug in is 0, well, I already did that for my vertex. I'm actually going to get the same point back again. I'm going to get 0, negative 9 again, which I've already graphed. And I can't reflect it either because I'm sitting on my y-intercept is actually on the axis of symmetry. It's 0 points away. So I really can't do any of those. So in cases like that, you could either just try to sketch this. You're probably not going to get a really good V-shape when we only have, U-shape parabola when I only have 3 points. So what you might want to do in cases like this where the y-intercept and the vertex are actually the same and you can't get those other 2 points that you need is to just go back to the old xy table. I can plug in something. I can say, well, let's try plugging in x is equal to 1. Right? If I plug in x equals 1, I'm going to get some point in here, and that's going to give me my nice kind of shape for the parabola. So I'm actually going to say, let's pick the point x is equal to 1. This is not a special point. You could have picked 2 or something else. But I'm just going to say, let's plug in 1. Let's find out what happens. So I'm going to plug that in, and I'm going to say that is equal to y is equal to 1 squared minus 9. Well, 1 squared minus 9 is equal to 1 minus 9, which is negative 8. Okay? So I can say when I plugged in 1, I got back negative 8. That's a point. 1, negative 8 is right here. And I can reflect that. That's going to be that one right there. Right? So if one of our 5 key points doesn't work, you have some backup plans. You can always fall back on that XY table, and that should do the job. Right? So this is my basic sketch of the parabola here. Okay? So you have some backup plans. We're not stuck using these 5 key points. They're important points, but sometimes they're actually the same. The vertex and the y-intercept happen to be the same point, and that's going to happen, and we can always go back to the old XY.